Let's begin with the new chapter that is called surface chemistry. So what do you mean with this? As the name indicates, surface. Surface means if you take this, my hand is it. So this above face, that is called surface. This is called below surface. So the surface chemistry is nothing but it is a branch of chemistry that deals with the various phenomena occurring at the surface or interface that we are going to call as the surface chemistry. Mainly we are going to study in this chapter is some colloids, adsorption, catalysis, right? So before going to study the adsorption, so just the word difference we are going to catch it here. This is called adsorption. Adsorption and absorption. The pronunciation may be similar to that one, but the one word difference that is called D and B. So that makes a lot of difference in this phenomena here. So one is called adsorption, one is called absorption. So according to the surface chemistry, the adsorption is a phenomena that comes under the surface chemistry. But this is not comes under it. But anyhow, before going to study this one, adsorption, so let's discuss about the absorption. So let's start with the absorption. What do you mean by absorption? In one substance, the other substance enters and distributes the uniformly throughout the bulk quantity. That is called absorption. So in order to understand this one, if I take a sponge you know, right? So if I dip that sponge in the water, what happens? The water molecules which directly enters into the sponge, right? Then the sponge becomes wet, right? So that is called absorption. See, in this phenomena, the sponge which is going to take in the water, right, the water towards this one, that is called the water molecules which enters into the sponge, right? So that is called phenomena absorption. So in one substance means that is called sponge. In sponge, other substance means water that enters and distributes uniformly throughout the bulk, that is called absorption. If you take so many examples for this one, absorption. So if you take the teacup, right? So in the teacup, what happens? You are going to dip in the biscuit, right? So what happens? That the biscuit become, when you dip into the tea or coffee, that becomes what? Wet. So right? So that means the tea molecules, right? Tea molecules or the coffee molecules which directly enters into the biscuit, that is called absorption phenomena. They are going to take place there. And also one more example, that is called your favorite gulab jamun. Right? So what happens in the gulab jamun, when you cut into the pieces, what happens? The wet portion will be coming out. That is called pak. That gulab jamun pak that enters into the gulab jamun, right? So that is also phenomena we are going to use, that is called absorption. And one more, that is called chalks. These chalks, when you are going to dip in the water, what happens? The water molecules, they are going to be involving, right? So the process that is called absorption, the water molecules will make wet these chalks, right? It means the water molecules which enters into the chalks. So all these phenomena we are going to call as the absorption. So that is called in our daily life we are going to study these phenomena. And the substance which is being absorbed, that is called absorbate. That we are going to call as the absorbate. So that is called, if I take this sponge and water, that water becomes here absorbate, because the substance which is being absorbed. So which molecules? The water molecules which are going to be absorbed here, that is called absorbate. Sponge is an absorbate here, and water is an absorbate. So next, the substance which absorbs the water molecules, that is called sponge or chalks, we can tell here. So that is called absorbent. Similarly, in one word, that is called solute plus solvent, right? So here the solute is sponge, solvent becomes water. And also more example, solute means chalks, solvent means water. So that is also phenomena comes under the like this, that is called absorption. Let's discuss about the adsorption phenomena. So that tells it, so the process of accumulation of the molecular species, that molecular species may be gas or liquid. So that is molecular species on the surface than in bulk of a solid or liquid, that we are going to call as the adsorption. So in order to take this one, so simple example I am going to take it here. So just so this is a board. Now I am going to writing something on this board, right? So if I write something on this board, what happens? The chalk particles which are going to be accumulated on the surface of the board, right? So that is called absorption. In one phenomenon we are going to tell that it is called adsorption. If I write something on this board, right? So the what I am going to write from using these chalks, so that is called accumulation. These chalk particles which is going to be accumulated on the surface of the board, that we are going to call as the adsorption. So here the process of accumulation of the chalk particles on the surface than in the bulk of a solid or liquid, that we are going to call as the adsorption. So the best example is chalk and board. So right, that make use of this one, the phenomena we are going to occur in, that is called adsorption. And next one, the molecular species that accumulates on the surface, that is called chalk particles, which accumulates on the board, right? Accumulates on the surface of that board, that we are going to call as the adsorbate. So chalk molecules on the surface. In other words, on one substance, another substance which accumulates on the surface of that solid or liquid, that we are going to call as the adsorption. And the material on which adsorption takes place, that is called adsorbent. So this board we are going to call as the adsorbent, because which has the capacity to accept the chalk particles, that is called material that provides the phenomena, that is called adsorption, that is called, we are going to call as the adsorbent. And so we can take one more examples also this. So this chalk, if I dip in the water solution, that becomes the absorption. Suppose if I dip this chalk in the ink, right, ink molecules, that is called blue ink, anything. If we dip it in the ink pocket or ink solutions, what happens? Those ink solutions which gets adsorbs on the surface of the chalks instead of the that is called instead of the enter into the substance. If that enters into the chalks, that is called absorption. If the accumulation of the ink particles on the surface of the chalks, that we are going to call as the adsorption. So this is a one word, that is a D and B, that tells that a lot of difference in between them, right? So that is called the adsorption. And the removal of the adsorbed surface from a surface, that is called desorption. So just it is an opposite of this one, adsorption. Desorption is just opposite to the adsorption. Why? Because so adsorption tells that the accumulation of the molecules on the surface of that solid, that we are going to call as the adsorption. But in the desorption it tells that the removal of the adsorbed substance from the surface. So if this suppose if the ink particles, suppose I am going to take this board only. If I remove the what I am going to written on this board, if I remove that one, that is called desorption. If I write something on the board, that is called adsorption. So this is a simple difference in between the adsorption and the desorption. And next one, both the adsorption and absorption can take place simultaneously, that we are going to call as the sorption. Sorption is the both adsorption as well as absorption simultaneously they takes place. They takes place in the involving the phenomena, that we are going to call as the sorption. We have studied the adsorption, right? Then what is the reason for this adsorption? Why it has to take place here? So let's study about this one. So now I am going to take a simple experiment here. So this is an beaker. I am going to take a container. So in the container, all the water molecules are going to be filled here. So this is called a surface. This is called opener of the container, and this is called the surface. So surface of this liquid, water liquid surface, right? So what happens when you consider the molecules here? So this is a container, water molecules are going to be filled in the container, and this is called the surface of the water molecules here. So now I am going to consider the one molecule, right? So that is called inside the water molecules. Now I am going to consider the one molecules. So that is called, when I consider this molecules, that is in the bulk, right? This is called bulk phenomena. In this what happens, in this inside what happens, this is going to be balanced by some other molecules also. I mean, it is going to be surrounded by so many molecules, right? That is called, here one molecule will be there, here one molecule, and here also one molecule will be there, here also one molecule will be there. So this is called a balanced force. When these molecules, which is going to be surrounded by some other molecules in the bulk of this inside the container of the water molecules, so this is called a balanced one. This is called a balanced one. So due to this balanced form, this is called balanced force will be here. This is called, we are going to call as the stable one. So this is called stable one, hence it is going to be occupying the less energy. So when you discuss about the phenomena, this is in the bulk of this liquid. When you study inside the beaker, that is called inside the container. But what happens at the surface of this one? So here also I am going to consider one molecule here. So this molecule is also going to be surrounded by some other molecules like this. But its upper position will be vacant position. So this is called vacant position. Why it is vacant? Because of at this space, this is called surface of the water molecules. There is no further water molecules. Because when you study inside this one, so this is going to be surrounded by some 4 molecules. If I am going to take an example here, so this is called an unbalanced one here because of this vacant position. Why this vacant position has arisen here? Because of the surface which is going to be end here. So that is called, this is called unbalanced. This is called an unbalanced here, and also this is called an unstable. This is called unstable, but energy will be very high here. So in order to take adsorption, some other species will come here. If I put some other species, just take an example here. What happens here? So this chalk I am going to dip it in the ink pad, ink solutions. What happens? Those ink solutions which is going to be adsorbed, accumulates on the surface. Like this also, I am going to dip in these chalks here in this ink pad, ink container. So this molecule is nothing but the chalk particles, chalk. So I am considering here. So what happens here? The force of attraction will be very high. Why in this position? These molecules will come and attract on this one. Why? Because the force of attraction, that is called the force of attraction, is very high here. Very high on the surface of this liquid. Because why? Because this position is unbalanced and unstable and high energy will be there. So due to make this balanced form, this one or become stable, so these molecules will accumulate on the surface of this liquid. Now it is going to be called as the adsorption. So this is the reason we are going to finding here, right? So that's why if I put the chalks in the ink pad, so what happens? The molecules, in order to maintain what happens in the ink pad, what happens in order to maintain the stable form or balanced form, so that's why the chalk particles which is going to be accumulate on that surface here, so that is called, so now we are going to call this as an adsorption. So like this, these molecules will come and attract here. So this is the reason chalk particles gets adsorbed by the ink particles or ink molecules. When these molecules will occupy this accumulation of this surface of this one, so what happens at that time? The energy is going to be released here. So the energy which is going to be released here. So the energy released we are going to call as the exothermic. That is called exothermic. That is called heat is going to be evolved here. So at this stage, when these molecules will come and occupy this one in order to make this balanced one. So this surface is vacant now. When these molecules which accumulates on the surface here, the energy is going to be released. So that is we are going to call as the exothermic. After studying the two phenomena, let us study about the distinctions between the adsorption and absorption. What are the difference in this one? So let's study here. Adsorption, you know the definition very well. So it is a surface phenomena. So if this comes under the surface phenomena, this comes under the bulk phenomena. So there is a higher concentration of adsorbate on a surface than in the bulk, whereas this one, the concentration is uniform throughout the bulk. So in one mode we can tell that the one substance which can enter to the other substance, that is called adsorption, or one substance, another substance which accumulates on the surface, that is called the adsorption. So that is what one of the definition we can give here. So this is an adsorption is an exothermic process. As you have seen how the exothermic process will takes place in the adsorption. But what about this in the absorption? Neither exothermic nor endothermic. So that is what one more difference here. And next one, the rate of the adsorption decreases with a decrease in the availability of the free surface. But here the rate of the absorption is uniform or constant throughout this process. So first we should understand this one, how the rate of absorption decreases. So if I take any substance here, right? If I take any substance here, there will be empty space will be there, right? There will be empty space will be there. The coming molecules which wants to accumulate on the surface of this solid, so what happens? They will come and occupy these places, these empty spaces, right? So it was initially, that is the rate will be very high, but when the process will be continuously goes on, the what happens, the availability of the free space that goes on decreases. That's why the rate also goes on decreases. But in absorption, it is not like this. So what happens, that is what throughout uniform, because our definition tells that the uniformly we are going to maintain the throughout the phenomena. So that is called the absorption here, right? This is called constant process we are going to see here. But whereas in absorption, only the matter of the free availability of the surface. So if I take the example of this board only, if I write all this, if I writing the all this board covered with no portion to be left out here, then is it further adsorption takes place? That is not possible, because the writing the chalk particles, chalk on this board where the free availability space will be there, that I am going to take this writing part here, right? That is called as the adsorption. If I fully cover this with the board with the chalk particles, if remaining, if anything left out to write down, so that is not possible, right? So like this also here, that is matter of the free availability of a surface. So that is called adsorption. And also you can take the examples for this one, that is called absorption, that is called chalk particles when dipped into the water solution. So that phenomena comes under the absorption. Whereas in this adsorption, if I dip this chalk one in the ink particles, ink solutions, what happens? That ink molecules which gets accumulates on the surface of that chalks. That is called example for the adsorption. So many examples we have seen on this one.